This video is on naming and writing formulas for ionic compounds, and we'll be using the lecture notes that look like this. And we will be completing the front and kind of this first section on the back, and we'll leave this second section for a separate video. Okay, so naming and writing formulas for ionic compounds. So the first thing we need to discuss is what an ionic compound is. Technically, they're called binary ionic compounds, and binary just means two, so don't let that confuse you. So an ionic compound is composed of a metal and a nonmetal. And this is not new information, this is old information. Composed of a metal and a nonmetal. The other way you could say that is a cation and an anion. Of course, cation being positive, anion being negative. Okay, so you always have a positive and a negative in an ionic compound, and they involve electron transfer. Okay, so that means that there's always one element who is losing electrons, and there's one who is gaining electrons. That's always the case in an ionic compound. You might remember that we learned about covalent, which of course is sharing of electrons, but that's a story for a different day in terms of how we name and write formulas. So this is just naming and writing formulas for ionic compounds, which are composed of a metal and a nonmetal. You could say cation and an anion, and they involve the transfer of an electron or of more than one electron. So, okay, so there are three rules that we're going to learn how to write formulas first. And there are three rules we have to follow to write formulas for an ionic compound. So if you'll notice your paper has 1, 2, 3, and then practice at the bottom. If you would write these two practice names in, this one's magnesium oxide, and then iron with a Roman numeral 2, and I'll teach you all about that, chloride. If you would write those in the practice section, we'll actually learn the rules and then practice with these two examples as we go through the rules. Okay, so the first rule, when I encounter a name, okay, so magnesium oxide is the name of a compound. The first rule to writing the formula is to identify the ions and their charges. Okay, so identify the ions and their charges. So in this first one, it's fairly simple. I have magnesium, and so if you look on your periodic table, of course, magnesium is Mg, and magnesium's charge is +2. I gotta scoot back just a little bit. Okay, magnesium's charge is +2. If you don't remember where we got that from, your periodic table should be labeled, remember, +1, +2, +3, this one skipped, and then -3, -2, -1, and 0, right? Those are charges from the discussion of satisfying the octet rule and gain and loss and all that good stuff. So, okay, so magnesium's +2. Now, oxide, okay, is not on your table, but that's just oxygen, and there's a reason why its name has been changed, and we will cover that very shortly. So, oxide is just oxygen, so I look up oxygen. Oxygen is O, whoop, and then oxygen is -2. Okay, so magnesium +2 and O -2. I'm going to do the same thing for the second example. So you see iron, okay, so iron symbol is Fe. But when you go to look up iron in your table, iron is a transition metal and is in this section. And we have learned up to this point that we don't know the charge of iron. And so what we will learn a little bit later on is that we have to identify those charges, because you should be saying, I don't know what iron's charge is. So that's why the Roman numeral is there, okay? Iron is a metal, and so all metals lose electrons and they become positive. And this Roman numeral is trying to tell you that iron's charge is +2, okay? And it's as simple as that. So this is iron +2. Now you might be wondering why magnesium didn't say magnesium Roman numeral 2, and that's because we know magnesium's charge, okay? It can never be anything but +2. So if it's a transition metal, you're going to see very quickly that transition metals will always be accompanied by that Roman numeral, okay? And then chloride is chlorine. Again, we'll learn why the "ide" later on. And so chlorine is Cl, and chlorine's charge is -1. Okay, and again, I'm getting that from my table. All right, so rule 2. All right, this is a very important rule. So rule 2 says, only if needed, we're going to add ions so that the charges add up to 0. And this has to be true in every single ionic compound. So this is something I always have to consider. So in my first practice example, I have magnesium +2 and O -2. If you think about the charge +2 and -2 and you add them together, you get 0. So in this first example, everything is good. My total charge is 0. So I don't have to do anything. But in my second example, I have iron +2 and chlorine -1. If you add +2 and -1, it's not 0. So I can't leave it like this. I have to have my charges that add to 0. So I need to add either more iron +2 or more chlorine -1 to get my charges to add up to 0. So you might not be surprised to know that if I were to add a second chlorine, okay, who's also -1, all of a sudden now I have +2, -1, and -1, which is in fact 0. So I have now balanced out my charge on my second example. And that was rule 2. And then rule 3 is to, let's see,